Assalamu alaikum, dear students. Today we discuss if sine of alpha is equal to 4 over 5 and cos of beta is equal to 40 over 41. 0 is less than alpha is less than pi by 2 and 0 is less than beta is less than pi by 2. Then show that sine of alpha minus beta is equal to 133 over 205. 0 less than alpha less than pi by 2 means alpha lies in first quadrant, and similarly beta is also lies in first quadrant. Now start the solution. Sin alpha is equal to 4 over 5 and cos beta is equal to 40 over 41. We know that sin of alpha is perpendicular over hypotenuse. By comparing, we have P is equal to 4 and H is equal to 5. By Pythagoras theorem, hypotenuse square is equal to base square plus perpendicular square. 5 square of 5 is 25 is equal to b square plus 16. 25 minus 16 is equal to b square. So we have b square is equal to 9. Taking square root on both sides, we have b is equal to 3. b is equal to 3 and cos alpha will becomes base over hypotenuse. So we have 3 over 5. Cos beta, we know that cos function is base over hypotenuse. So we have b is equal to 40 and h is equal to 41. By Pythagoras theorem, h square is equal to p square plus b square. Putting the values of h and b, 41 square is equal to p square plus 40 square. 1681 is equal to p square plus 1600. 1681 minus 1600 is equal to p square. P square is equal to 81. Taking square root on both sides, p is equal to 9. By using this value of p, we can find sin beta perpendicular over hypotenuse. It will become 9 over 41. Sin of alpha minus beta. By using the formula, sin of alpha minus beta is equal to sin alpha cos beta minus cos alpha sin beta. Now putting the values of all four functions, we obtain sin alpha is equal to 4 over 5. Cos beta is 40 over 41 minus cos alpha is 3 over 5 and sin beta is 9 over 41. Which is equal to 160 over 205 minus 27 over 205. Taking LCM as 205. 160 minus 27 over 205, which is equal to 133 over 205, which is right hand side as required. Left. Question number 9. If Sine alpha is equal to 4 over 5 and sine beta is equal to 12 over 13, where pi by 2 is less than alpha is less than pi and pi by 2 is less than beta is less than pi. Then find part number 1, sine of alpha plus beta. Part number 2, sine of alpha minus beta. Part number 3, since here given that sine of alpha is 4 over 5 and sine beta is 12 over 3 and pi by 2 is less than alpha is less than pi, it means alpha lies in second quadrant. This means alpha lies in second quadrant, and this means beta is also lies in second quadrant. And we know that in second quadrant sine is positive while cos and tan are negative. Now we start the solution. Now consider, given that sine alpha is equal to 4 over 5 and sine beta is equal to 12 over 13. Since we know that sine is perpendicular over hypotenuse, so P is equal to 4 and H is equal to 5. By Pythagoras theorem, H square is equal to P square plus B square. 25 is equal to 16 plus B square. 25 minus 16 is equal to B square. So B square is equal to 9. Taking square root on both sides, B is equal to 3. So we have cos alpha. Cos alpha is equal to minus B over H. As cos alpha is base over hypotenuse, negative sign due to second quadrant. Negative sign is due to second quadrant. Alpha lies in second quadrant and we know that cos alpha is negative in second quadrant. So we have the value of cos alpha minus 3 over 5 and tan alpha is equal to perpendicular over base, and also tan alpha is negative in second quadrant, so we have tan alpha minus 4 over 3. Similarly, sine beta, sine is also perpendicular over hypotenuse. P is equal to H is equal to 13. By Pythagoras theorem, H square is equal to P square plus B square. 169 144 plus B square. 169 minus 144 is equal to B square. B square is equal to 25. Taking square root on both sides, B is equal to 5. So we have cos beta and tan beta. Cos beta is minus B over H is equal to minus 5 over 13, and tan beta is equal to minus B over B is equal to minus 12 over 5. Since beta lies in second quadrant, therefore value of cos beta and tan beta will be negative. After finding these four values, we start first part of this question. Sine of alpha plus beta is equal to sine alpha cos beta plus cos alpha sine beta. Putting the values of sine alpha cos beta, given that sine alpha is 4 over 5 and cos beta we have find that is minus 5 over 13, plus cos alpha minus 3 over 5 and sine beta given that 12 over 13. To simplifying these fractions, minus 20 over 65 or minus 36 over 65, which is equal to minus 56 over 65, which is required answer for sine of alpha plus beta. Now we find second part, sine of alpha minus beta is equal to sine alpha cos beta minus cos alpha sine beta. Putting the values of sine alpha is given that 4 over 5 and cos beta minus 5 over 13 minus cos alpha minus 3 over 5 and sine beta 12 over 13, which is equal to minus 20 over 65 and plus 36 over 65, and minus into minus is equal to plus. Taking LCM, we obtain 16 over 65, which is required answer for sine of alpha plus alpha minus beta. Similarly, we can find cos of alpha plus beta, cos of alpha minus beta, and tan of alpha plus beta and tan of alpha minus beta. We know that the formula for cos of alpha plus beta is cos alpha cos beta minus sine alpha sine beta. We know that value of cos alpha minus 3 over 5 and value of cos beta minus 5 over 13. Sine alpha is given 4 over 5 and sine beta over 13, which is equal to 15 over 65 minus 48 over 65. Taking LCM, 65, which is equal to minus 33 over 65. Part number 4, cos of alpha minus beta is equal to cos alpha cos beta plus sine alpha sine beta. Cos alpha is equal to minus 3 over 5 and cos beta minus 5 over 13 minus sine alpha 4 over 5 and sine beta 12 over 13. We obtain 15 over 65 minus 48 over 65. Taking LCM, plus, here we have positive sign, which is equal to 63 over 65. Part number 5, tan of alpha plus beta. We know that tan is equal to sine over cos sine of alpha plus beta over cos of alpha plus beta. We have found that sine of alpha plus beta, sine of alpha plus beta is minus 56 over 65 and cos of alpha plus beta is minus 33 over 65. So we have 56 over 33. Part number 6, tan of alpha minus beta similarly is equal to sine of alpha minus beta over cos of alpha minus beta. We know that value of sine of alpha minus beta is 16 over 65 and cos of alpha minus beta is 63 over 65. So we have 16 over 63. We can see that cos of alpha plus beta is negative, sine of alpha plus beta is negative, cos of alpha plus beta is negative, but tan of alpha plus beta is positive. This implies that since sine of alpha plus beta is negative, cos of alpha plus beta is also negative, but tan of alpha plus beta is positive. This implies that alpha plus beta lies in third quadrant, and sine of alpha plus beta is positive, cos of alpha plus beta is positive, and tan of alpha plus beta is also positive. This implies that alpha minus beta lies in first quadrant. The only quadrant in which sine, cos and tan are positive is first quadrant, and the quadrant third, in which sine and cos are negative but tan is positive.